Okay, so there are 4 different types of conversion factors, or 4 basic ones, okay? The first one's the molar mass, which I know you know how to find. It takes you from moles of a chemical to grams of a chemical, or grams of a chemical to moles. And you find that on that periodic table, okay? The second type we have is the mole-to-mole ratio. And the mole-to-mole ratio is used when you want to change the chemical you're talking about. So if you have a problem that goes from carbon and it goes to carbon dioxide, you're going to use the mole-to-mole ratio, okay? And that is found using your balanced chemical equation, okay? And you also have Avogadro's number. And the key words to look for, and you know you're going to use Avogadro's number if you have the word atoms, particles, or molecules, okay? And if you have one of those, you can convert it into moles by using the conversion factor of 6.02 times 10 to the 23rd, whatever one of these you have of a chemical, equals 1 mole of that chemical. Okay, and the last one, and I don't know if you guys have gotten to this yet, but this is the last one that you're going to have, is the gas conversion at standard temperature and pressure. Okay, and it's only used with gases in the gas form. Okay, so you have 22.4 liters of a gas is equal to 1 mole of that gas. Okay, so those are the 4 ones that you're going to be dealing with, and stoichiometry is just using these 4 different conversion factors to get to whatever thing you're looking for, okay? And that's the trick, is to figure out which one you need to use. So let's look at this problem, okay? Okay, here it is. Okay, what mass of hydrogen peroxide must decompose to produce 48.64 grams of water? Okay, well, first I have to write an equation for that. And hydrogen peroxide is decomposing, okay? And you know water is going to be the one of them, okay? So hydrogen peroxide, whoops, I'm going to make some more room here. Hydrogen peroxide is H2O2, right? Because peroxide is an O2 negative 2 ion, so H2O2, okay? Plus oxygen and water. You know water is going to be out. Now, is this balanced? 2 hydrogens, good. 2 oxygens, 3 oxygens. So that's not too good, right? So we have to figure out how to balance this. Well, I know this has to be even number, because this side's always going to be an even number of oxygen, so I have to make this an even number. So I am going to put, a 2 here, and if I need to play with it later, okay, so 2, okay, and so that means now I've got 4 hydrogens, right? And so I'm going to put a 2 over here to make 4 hydrogens. Now let's check this. 4 hydrogens, 4 hydrogens, 4 oxygens. How many oxygens do I have? 2, and then 2 oxygens for here. That says 4. So this is your balanced equation, okay? Then we write down what we're given, okay? We are given this, 48.64 grams of water, okay? What are we looking for? Well, it says up here, we are looking for the mass of hydrogen peroxide. So I need to find the mass of hydrogen peroxide. And the mass of hydrogen peroxide is going to be in grams of H2O2. Okay, now I see a lot of grams, right? So I know whenever I see grams, I'm going to find molar masses, okay? And since we're not in the same chemical, right, I know that I'm going to have to use that molar, or the molar ratio, the mole-to-mole ratio from this chemical equation, okay? So my thought process is, well, first balance the equation. I already did that. The thought process is that I can't go directly, from one chemical to the other, okay? You have to go through the moles. If you're in grams, you can't directly go to grams of something else, okay? So you have to go through moles. So it's going to look like something like this. I'm going to go from grams of water to moles of water, right? And I'm going to go from moles of water to moles of hydrogen peroxide, and moles of hydrogen peroxide to grams of hydrogen peroxide, okay? So what am I using? I'm using the molar mass, the mole-to-mole ratio, and the molar mass of this. So now you have to find all these little equations or little steps, okay? So I can say that 1 mole of water equals 18 grams of water. You know that by now. 2 moles of hydrogen peroxide is 2 moles of water. Where is that coming from? That's coming from up here, okay? So this chemical equation up here actually has a whole bunch of conversions. It says 2 moles of hydrogen peroxide is 1 mole of oxygen. 2 moles of hydrogen peroxide is 2 moles of water. And 1 mole of oxygen is 2 moles of water. So there's, what, 3 equations all in there? Okay. So it's much easier to write it like that. Okay. Smooth those. Okay. So we have all those conversion factors. Okay. So now we start with what we're given. Okay. We start with what we're given. 48.6 grams of water. Where are we going to go? We do not want water. Remember, our first step is we're going to get it into moles. You can go a lot of places for moles. There's only one place you can go from grams. So let's get it into moles, and we're going to use that conversion factor. Now I want to get rid of grams of water. So on the bottom of this, I'm going to write 18 grams of water and 1 mole of 1 mole of water. Okay. So now the grams cancel. Oops, sorry. This is actually hard to do one-handed. So this one cancels and that cancels. So now I'm in moles of water. Well, I don't want water. And I know when I'm in moles, I can convert to another chemical. Okay. And I know that 2 moles of hydrogen peroxide is 2 moles of water. I want to get rid of moles of water. So moles of water is going to go down here so I can cancel it out. So I'm going to write 2 moles of water down here and 2 moles of hydrogen peroxide up here. Okay, so then cancel. Yep. Yep. Okay. So now I'm in moles of hydrogen peroxide, but it said it wanted the mass of hydrogen peroxide. So I'm going to convert that into using the molar mass. Remember, moles is going to go down here because I want to get rid of moles of hydrogen peroxide. So I'm going to put moles of hydrogen peroxide down here so I can cancel. And then I've got grams of hydrogen peroxide up here from the equation from the periodic table. Okay, and put 35 up there. So then this cancels with that. And then I multiply all these across. And then I hit equals. Then I hit divide by 18 equals. Divide by 2 equals. And you'll get approximately 92 grams of hydrogen peroxide. Okay, that's your basic stoichiometry. If you want me to do a limiting reagent one, I will be happy to do that. But this is basic stoich. Just let me know.